Frequency table means this is probably one of the worst answered questions in the exam. There's no need for that. If you know what you're doing, the maths is fairly straightforward. Imagine we measured the height of 10 sunflowers. These are the heights. Now, if I was finding a mean normally, I would add up all of these heights, but there's 10 of them, and then I would divide by 10. Total heights divided by the number in the sample, 267 divided by 10, 26.7. Pretty straightforward. But we're not going to do that. We're going to create a frequency table. I'm going to collect all of these heights into three groups: 10 to 20s, 20 to 30s, 30s to 40s. And I'm going to form a frequency table. These are the heights, and this is the frequency. The heights are in ranges: 10 to 20, there's 2 of those, 20 to 30, there's 5, and 30 to 40, there is 3. And this is a frequency table. We don't see that. This is all that's given to us in the exam. We don't know exactly where these two lie between 10 and 20. They might both be 11, but they might be 18. We don't know. That's why we can only make an estimate. But we're going to assume that they lie roughly around the midpoint. That's the best estimate. The midpoint of 10 to 15 is, 10 to 20 is 15, 20 to 30 is 25, and 30 to 40 is 35. So we are assuming that these two are 15. Therefore, midpoint times frequency is an assumption of the total height contributed by these two. Similarly, 5 times 25, 125 is the total height contributed by these 5, and 105 is an estimate of the total height contributed by these 3. So these are estimates of the total height for each class, which is a row. We're going to add them up to get an estimate of the total heights of all of these flowers. And we want to know how many flowers they are, so we will add these up. We're told at the beginning, but thankfully we've still got 10. Bit worrying if we didn't. So now when we come to find the estimated mean, it's an estimate because we don't use the actual heights, we just use the estimate, which is the midpoint. So then we use the midpoint times frequency, or the total heights, total estimated heights divided by the number in the sample, which is 260 divided by 10. Keep the math simple, 26. So, slightly different answer, and that's because a lot of these were higher than the midpoint, and that pushed up the real mean, but it kept the estimated mean at 26. Let's just analyse what we did from the point of view of someone who's just been given this. We only get the summary, we only get the frequency table, so we have to do several things. There's no other way around it. We extend, to find the estimated mean height, that is, we extend the table. Midpoint, mid times frequency. Midpoint's easy, 15, 25, 35. Right, I would expect that. Midpoint times frequency, 30, 125, 105. These are estimates of the total height contributed by these rows. And we add them to get an estimate of the total heights. And we add this to find how many is in our sample. And then we divide 260 by 10 equals 26. So let's see if we can think of a way of remembering this, because it is quite complicated. Firstly, add the midpoints, mid. Then multiply midpoint times frequency. Then you add this column. Then you add this column, if necessary, to find out the total frequency. Then you divide the total estimate for the height by the sample size, and then you're done. How do you remember that? Well, you remember it. Mid, multiply, add, divide, done. Or as I like to say, mad. But it helps. So, let's have an example. So instantly you can see that this is some sort of frequency table. These are the number of times it happens. This is the snowfall. And you can see it's all about the snow in this place during January. So hopefully there'll be 31 days. So we will have, well, there's a look at our I call it a mnemonic or phrase, help us remember. Midpoint, multiply, add, divide, done. We'll have a little think. We're going to use MAD because it's a frequency table. We're going to write mid and mid times frequency. Sometimes this is a bit tight because there isn't enough space on the page. So plenty of space here. Midpoint, 0 to 20 is 10. 20 to 40 is 30, so that comes down. That's fairly easy. Mid times frequency, 1 times 10 is 10. 8 times 30, 240. You get the idea. That's the multiply. Next is add. Add. Got to stop that. 1,730. And then we add these, the number of days, the number in the sample, 31. Bit of a relief. So now the mean is equal to the estimated total centimetres of snow, total estimated snow, divided by the number in the sample, which we know is 31. 31 days, January, etc. So that is equal to 1,730 divided by 31, which is, as you probably know, equal to 55.81. It doesn't say how they want your answer, but this clearly would show that I know what I'm doing, and it is indeed the correct answer, but I'd check anyway. I'd check the calculation. If there's time, if I'm in a rush, I might not, but I'd certainly check if it was reasonable. 55.8 is in this category. It's not the middle, because the middle's 50, but it's probably going to be higher anyway, because there's 6 big ones, big snowfalls, and only 1 small snowfall. So it's probably going to push the mean a bit higher. So yes, happy with that, 55.8. So what do? We think, we calculate, and we check. Let's have a look at another question. Don't like this question. I much prefer my data to be in a sort of column format. But it's the same thing. Here's a price per track. Here's a frequency. We've got 5 of them at 70, 1 at 80. This is clearly a frequency table. It's got the word frequency, a bit of a clue. So think, I'm going to use MAD. And I could, alternatively, just write down all of the actual costs in pence. We know there's 5 times 70, 5 of them. There's 180, 290s, 200s. I could do that. I could add all these up. But I'm going to use the same format as MAD, just so you get used to it. First thing we do, we don't need a midpoint because we have actual numbers. These are approximate prices. But we've got actual numbers. There's nothing I can do with that. I'm going to have to use those. So I use the price times the frequency. So 70 times 5, 350, 80, 180, 200. So that's my price times frequency. And now I add 810. I add to find the number of tracks in total. Well, there's 10. So now I did the calculation. Mean equals the total pence divided by the number in the sample is 810 divided by 10 is 81. That's my estimate of the mean price. In this case, it's an estimate not because we're looking at a range, but because the prices themselves are approximate. But there's nothing else we can do. We have to use them. And then I check, of course. So we have a look at the calculation. I'm not going to see anything in that. Is it reasonable? 81. 81, well, we've got from 70 to 100. So 81 is lowball, but we've got a heavy weighting of 70s. So probably go along with that. That looks fine to me. Give yourself a moment of joy. So we have a little think. We decide it's a frequency table and that we're going to use MAD. MAD. Then we do the calculation. Then we check it. By the way, don't say MAD in the exam because that won't go down well. So if we had a process, what would it be? As always, have a think. Is it a frequency table? Yes, it is. We've got the column, or a row in that case, of frequencies. So we're going to use MAD. That's the first thing. So let's do it. We midpoint. We find the midpoint times frequency. We do the addition. We do the second addition. We're well on the way, but there's something missing. Yes, this, D, for division. So we move on. Mean equals total estimated height. Number in sample is 260 divided by 10 equals 26. Excellent. And that's done. We'll have a little check and everything like that, but that's going to be right. So to summarise, midpoint, multiply, add, and divide. Then it's done. This is very hard. I'm being silly here. This is not tricky. It is hard. It is a very poorly answered question. And I think actually it probably goes from hard and remains quite tricky because it's long. But there's 4 marks available. 4 marks late in the exam. It comes up more than half of the years. So worth knowing about. It'll never be easy. But anyway, it's a nice graphic. If you found this interesting, even educational, why not subscribe? Loads of videos already, loads of videos coming. And if you're taking an exam in the near term, best of luck.